Thank you all for coming. Is everybody having a good night so far? Yeah? I hope you're all kicking on for the rest of Melbourne International Games Week as well. My name is, I just got a notification, got rid of that. My name is Ankur Kotwal, and I'm a developer advocate at Google. I've been in developer relations for about 7 years, and for a lot of that time I've actually been working with game developers. Originally started with working with Android and Google, or developers bringing products to Google Play. Moved on to Maps developer relations, where I was working with the team that was building the Unity SDK for Google Maps. And in more recent times, I've been, by the way, those Unity folks are right, the Maps Unity folks are right here, so say hi everybody. If you want to talk to them. In recent times, I've been working in the Google Cloud Developer Relations team. And one of the things throughout my career, I guess, that I've been really passionate about is the developer experience. And over these last few years, I've really been interested in how we can make the developer experience better for game developers on Google's developer platform. So I'm really, really passionate about this space. For some of you, this next few seconds might be a little bit of repetition from this morning, but there is a bigger audience here. So I just want to reiterate that a few months ago, Google and Unity announced a strategic alliance. We wanted to basically meld our minds where Google's been having strengths in building server-side infrastructure, and we wanted to bring that to game developers in partnership with, or with an alliance with Unity, because Unity is known for building great game developer workflows. And we are doing multiple things together with Unity, Google and Unity. The thing I'm going to talk about today is specifically on matchmaking. So, there we go. So let's begin today by talking a little bit, having a bit of an overview on matchmaking principles and why matchmaking itself is a very hard problem to solve for many developers today. But before I get started, just a quick show of hands. How many of you have multiplayer games or are working on games that have some sort of matchmaking component to them? Quite a lot, that's great. So at its core, the matchmaker is the front door to your multiplayer game. Everyone enters this door when they need to find others to play with. However, this pool is not homogeneous, and games can succeed without considering some specific attributes per player. So for example, here we've got a group of players that are ready to play. One of them is based in US West. They're looking for a battle royale game. They have a certain skill rating, and they want to play with their two friends who happen to be online as well. At the same time, we've got some players in Australia that have maybe a higher skill rating. They're looking to play with a slightly different mode of game. They're not looking for a battle royale. They're looking for some sort of competitive team game where it's 5 versus 5. They've got a specific class that they're playing. Maybe they're a healer or something along those lines. The point is that this is not an uncommon scenario, and you have to kind of be able to look at this and go, well, I'm going to group these people accordingly for various reasons. And what typically tends to happen is that the matchmaker's primary goal is to ensure the best possible player experience, such that they continue to want to play your game. Now, many developers achieve this or approach this using the trio of trade-offs. Now, for each game, the developer has to decide, well, how much latency can the player have or put up with and still have an enjoyable game? At what point will waiting in that matchmaking queue be too long and that they leave and never come back? And what happens if a match is totally imbalanced, where low-skill players are constantly getting stomped and high-skill players are sitting there going, this is not a challenging game? And actually, to take a step back from that, how do we even measure skill in the game? And it depends on the type of games we have. The ideal, of course, is to have the best possible scenario for all three, but that's not always possible, right? So instead, a common approach is to define acceptable bands for each of these, and then as the wait time grows, you start to loosen those bands to let more and more people in so that you can get a match going and people are able to play. But as a result of sort of taking that initial approach, some challenges that are often forgotten or underestimated include things like a sparse population. So what happens if there's only 10 people in the queue? And what if they're split across multiple game modes and are geographically far apart? it may be impossible for any of them to play the game at all, and now this becomes a design challenge for your game. What can you do to enable people of different skills or even latencies to still have an enjoyable experience? Then we have rapid scaling. Now sounds like a problem that many of us wish we had, right? Yet the horror story is that like your game is has become a viral hit, and unfortunately, because of this viral growth, suddenly your matchmaker becomes the choke point that prevents people from playing your game. How might you split up these large queues to distribute across more hardware? And then we get this concept of sweaty matches. I like this term, sweaty matches. There's been a lot of focus in the past several years on the best skill algorithms, and many of them have gotten so good. In fact, they've gotten so good that some games start to have this struggle with matches that are constantly neck and neck, that there's no one team dominating another, there's no team getting annihilated. And then you just end up with this sweaty intensity for the whole match, where it's a constant point of stress for your players. So at some points, game developers have started to wonder if prioritizing skill over other metrics is leading to the best player experience. You want to have flexibility because due to the complexity of matchmaking, developers often choose a path early in development. So it's going to work in the long term. However, most solutions don't tend to be adaptable. Once you kind of go down a certain path, you often get stuck with it. So what if you decide later on that you want a co-op mode as well? Or you want to try different metrics than that trio that we just saw earlier? This adaptability is rare today. And then there's the extensive infrastructure services that are required. Things like analytics, load balancing, maintenance with zero downtime, database instantiation, API backwards compatibility, and more. So first, let's talk a little bit about traditional matchmaker architecture. If you've been building a matchmaker a few years ago, a singleton might have been the typical approach. And the way that this works is that you have some players. On the left-hand side, we've got our players of those shapes and colors represent certain metrics about those players. And then you go ahead and find a big VM or actual machine to go and do your matchmaking. You connect all your players' client devices to it, and then you also connect all your game servers to it. You write some logic that chews through all the players, matches them, and puts them on the best servers you have available, and everybody is happy. This works fine until you have a massive hit game. Because as more and more players want to get into matches, you eventually run out of the ability to store all the players in memory. Or your matchmaking logic can't get through all of those players quickly, all that data quickly enough. Queue times go up in your game and sadness ensues. Well, it turns out this was a big problem in tech companies running online services a few years back too. And the solution to these issues was to scale out your task into more computers and handle all this data in stateless microservices. Who's heard that term before? Stateless microservices, yeah. Well, you may know this model. You store all the data in a fast database, and then you rebuild all your computational tasks such that you can run multiple copies of your code on different machines. And any one of them can access any piece of data, and now you can run more copies of your code to handle more load. It all sounds fantastic. The problem is that moving from a typical server architecture to a microservices architecture makes everything more complicated. Coding it is harder. Debugging it is harder. Operating it is harder. OpenMatch tries to close that gap by making a matchmaking service layer that we can all build on to get advantages while making things as simple as a singleton pattern where possible. So, when we decided to tackle this space in matchmaking, we decided to go and talk to lots of developers. And then when Unity also came on board, we spoke to more developers. And then in the last couple of weeks, we've published our open source repository. I've got the link for you. It turns out even more developers came and spoke to us. And time again, we've been hearing a few things from them all. that any matchmaker that's been built must be customizable. It must be able to run your matchmaking logic, not box you into like a few specific rules. OpenMatch can be completely customized because it's open source. Integration. Developers have said many established studios have multiple or even dozens of platform services that they already use to support their games. Things like authentication, things like party, things like chat, presence, and more. The cool thing about OpenMatch is it doesn't force you to move all your services across. You can just integrate OpenMatch for the matchmaking pieces and then continue to use whatever services you want. And the third thing that developers kept telling us is that they wanted to be able to run it anywhere. They wanted it to be agnostic. They didn't want to be locked into any specific cloud or commercial software. So if you want to run OpenMatch on your own cloud or your own hardware, you're free to do that. When it came to working out what kind of open source model we use, we followed Kubernetes. How many of you have heard of Kubernetes? Many of you. Fantastic. Kubernetes is something that was launched about 4 years ago. And it turns out that for over a decade at Google, we've been running microservices at scale for our production systems. Internally, that system was called Borg. And what we did is we decided to see what it would take to externalize that, to make that available to everybody. And Kubernetes was born. And we published that on, we made that available in open source, published it on GitHub. It's now one of the most popular GitHub projects out there. And it's been widely adopted by all the major cloud manufacturers, cloud providers. So we decided to follow a similar approach where we would make OpenMatch an entirely open source project, build a community around it, and then offer a managed version of that service, which is where the Unity integration comes in. Spoiler for a few minutes down the line. So the cool thing about it being an open source project is that we get a lot of contributions, and that's what we've seen in the Kubernetes world. A lot of the features have been driven by that community, and they've been implemented by members of that community as well. So contributions allow all of us to benefit. As more studios use OpenMatch, and for example, they start to build things like additional visualizations or custom matchmaking logic, their contributions, if they choose to provide them, levels us all up. And we can all start to tackle the more challenging parts of finding the best matches earlier in our game's life cycles. So whilst I said we've published the source code, we're still in alpha. Not everything is there yet. We're in active development. And we're working currently on building a foundation. So this is a great time to stand up an OpenMatch cluster and tell us what you want prioritized in the roadmap. So let's have a look at how OpenMatch, the sort of the main blocks of OpenMatch. So as with a traditional matchmaker, OpenMatch assumes that you have players and you have servers. What we then do is what we have done is built OpenMatch on top of Kubernetes. So that dotted line box there, that's where our components of OpenMatch exist. Now, there are plenty of one-click deployment implementations of Kubernetes. I often call out the Google Kubernetes engine because of my employer. But as I mentioned, there are other cloud providers. All the major cloud providers have their own Kubernetes implementations as well, and OpenMatch is agnostic there. So once you have a cluster, you can run the deployment scripts for OpenMatch, which is going to start up these 3 core components. The first one is the orchestrator, which is responsible for running your custom matchmaking logic. And I'll show you that in a second. Then we have the front-end API, which is what your game clients will connect to when they want to request a match, to make themselves available for being matched up. And then finally, we have the back-end API, which is where your server hosting and infrastructure operations department will use to administer the matchmaking. Now to these, you're going to add your custom matchmaking logic. And you'll do so in a Docker container. By virtue of the fact that it's a Docker container, it means you have a lot of flexibility. You can use any language, any libraries, and you have complete freedom to run any code there that you want. We'll just run the Docker container that you provide us. So from here, you're going to connect your backend and load up what we call matchmaking profiles. So let's say that you have a game that has a capture the flag mode and you want to play 4 versus 4. You have some metrics around specific latencies and so on. You define these profiles. I'm going to show you what a profile looks like when we do a demo. You define that profile. You say, here's my latency limit. I need teams of 4 and 4, and I call this mode capture the flag. And you define that profile. Once you've connected it to the backend API, you'll see that we get these rows across the top in the custom logic there. Basically, what that's saying is that's loading your profiles and trying to fill players in. So we now need to connect our players to the front-end API. So that happens, and it all uses a single optimized connection. So integration for that side is typically 3 to 4 lines of code. And then once the client contacts OpenMatch, the player will be entered into that matchmaking pool. Now, the orchestrator spins up your custom matchmaking logic, which will look at all the players in the pool and slot the players into the profiles which you defined. So if we have a look at this diagram here, the bottom 2 rows, we've actually managed to find players that fit those profiles, and we can kick matches off. Those top 2 rows, the top row, we still have a white triangle that's open, so we haven't quite filled that match yet. And the same thing with the second row. So we can kick off the ones that we've found, we've match made to fit our profiles. Now, once your match logic is finished running, the complete matches get sent out to the backend API to your servers or management layer. There's also a custom return path that isn't pictured here. Basically, this tells your backend to send connection details back to clients, so your clients know that to connect to this server, to this IP address on this port, and so on and so forth. So let's do a quick demo. Let me describe the demo. I'm going to just go back to this diagram here. So with this demo, it's not a particularly visual one, but what we're going to be doing is having a front-end client that generates a bunch of players, and then we're going to have a back-end client that goes in and says, hey, here are my profiles. I want you to go fill them up. So, whoops. There we go. So I've just got a little task running in the background that says how many players are waiting in our matchmaking pool. Currently, there's none. I'm just going to run this container that's going to go and generate players for us, and you'll just see they're just UUIDs. So the actual data here is all made up, but all we're doing is generating player IDs. We're making up which city they belong in, and we're randomly generating some latency numbers as well. Okay, so this is all fake data, but effectively, this is the kind of information that we might pass to our backend. And then now if I have a look at our rows, you'll see now we have 130 players waiting. So why don't we kick off our server that's going to say, hey, you know what? I want to go and get some players. Just spinning up that image right now. And here what we're saying is, I have this thing that I call a test profile. I want it in the region of Europe West 1. I want it to have latency of less than 150 milliseconds or less, a particular matchmaking rating. I'm saying that I want capture the flag here. And then in the roster, you'll see that it's generating blocks of teams of 4 and 4. So our profile basically had said, hey, I want 4 players here and 4 players there. So you'll see every few seconds, it's generating like basically kicking off a new match. I'll just wait for that refresh to happen again. It'll be a few seconds. It's just sitting there in a loop. There you go again. So it's just spinning off new clients. So I'm going to stop that. And I'm just going to show you what these profiles look like. So I'm just going to go into interactive mode into my image. There we are. So if can you all see that? Is that hard? Yeah, okay, you can see it at the back, okay. So if I just go ls profiles, you'll see I've got a few profiles defined. This test profile that I was using, profiles/test. you'll see that the test profile I was using was just here saying, hey, I wanted 4 players on blue and 4 players on red. What we can do now is actually, let's switch, oh, sorry, come on. What we'll do is we'll just change that 4 to 50. So we'll put 50 players on either side and then have that back end just kick off a bigger set of matches. So if I just have a look at our pool of players, we have 660-ish waiting. We've kicked off that profile here of 50, and then you'll see now it's generating, the back end is generating matches of 50 and 50 players. And these are just player IDs, and it will go ahead and do those. So that was a demo just showing how we can define these profiles, upload them, and so on. Now, let's switch gears a little bit. We've so far been talking about OpenMatch and the open source project. I want to shift gears and talk about Unity's integration, intended integration with how this will fit into the Unity world to make your developer experience better. So a guiding principle of this project is the idea of uncompromising flexibility. This really gives us a tool in our war chest to solve one of the really hard problems of matchmaking that folks have to constantly rebuild when doing game infrastructure. So as I mentioned earlier, you can download that open source project now, you can deploy it, you can start to integrate with it, but one of the difficult parts of shipping a game on this type of system is that it does take a whole lot of, a bit of work to get started running matchmaking as part of your own online connected games business. And this is where the Unity-hosted, Unity-managed version of the service is going to help you out. Unity will deploy a hosted version of this open source matchmaker and then integrate it with all the Unity services ecosystems that are necessary to run at this scale. So what we're going to do is make sure that we obfuscate some of the problems and issues that are typically associated with running a services organization of this sort. So let's dive into some of those guiding principles. For those of you, you may be familiar with some of these problems if you've built, deployed, and run live services before. Infrastructure, operations, scaling, monitoring, SLAs, keeping it up and running, deployments, and so on. These are things that Unity would like to solve for you with the hosted version of the service. This needs to work for whatever population your game is going to work on, is going to be running. And frankly, the more successful your game is, the better it is. So if you're a small studio that's just getting started and you have 5 people on your team all the way through a population of 10 million players, and you want to do any sort of segmentation or A/B testing, this system will be able to support you at scale. We're going to come back to the out-of-the-box part because we've got some more details about that. But I do want to say that the out-of-the-box part is really important to Unity, and this flexibility is the reason for integrating with this open source matchmaker. So when you submit customized information to the front door of this matchmaker, you can't just submit anything. Because, for example, you can't trust the clients to tell you what their skill rating is. What you need is a system that gets the player ID through the front door, authorizes these calls, fetches the skill information from your player database, and then augments that with whatever player data is required in order to kick off the matches. Now, these are services that Unity will also host along with the managed version of this matchmaker. So Unity wants to get you up and running as quickly as possible, especially with multiplayer games. Now, sometimes it's about that immediate brilliance, right? Like, I have an idea, it involves multiplayer games, and I want to have this prototype running very quickly. That's the kind of scenario that Unity wants to make much easier. So let's do an example of this amazing graphical multiplayer game all written up with transport that we've been testing on a local server. When it comes to take this live and take it to a small audience, what you're going to do is add the matchmaking package API, and then you add some simple callback requests for find match, I found a match, and update match information for that matchmaking. That's kind of it. That's kind of all the work that you have to do on the client side. The rest of the configuration, the rest of the tuning, and picking the type of match functions you're going to want to run, you're going to do all of that in the back end. And you'll be able to do all of this in the editor too. So I've listed a couple of match functions here, top ladder, normal skill, queue catch, and so on. Now, Google and Unity are working together on defining a series of canonical match functions. Now, these are going to be match functions that kind of address the typical types of problems that you may have, things like skill, things like coalescing servers into data centers that are near them, and getting that tight, low latency experience to the dedicated server. But you can also select a family of archetype mixes of these match functions, and these will be built in and made available to you. What's nice about these match functions is that there's nothing specific about them. So the idea is that you can actually ship your game on these functions. There's no difference between this and something that you might want to build. It's just this has been built to scale from the get-go. So the amazing power of GCP and multiplayer technology combined allows to do things like spinning up a dedicated service for your game. I'm going to talk about that more in a second. Once you've uploaded your image, your dedicated server image to the system, that's kind of it. You can now go and find a match, go into the matchmaker, and eventually it will find a match, it'll find a server, it'll pass out on that connection information back through your game client, and that prototype that we were doing with a small team, we can just get going, whether it's a small number of players or a large number of players. Now, this system allows us to provision dedicated servers specific to matches that have been spun out and minted by the open source matchmaker, in unison with the Unity managed version, allowing us to put servers as close to your players as possible. This is all going to be deeply integrated with the Unity managed matchmaker, so you don't even have to worry about this part. This slide is basically there to illustrate that we're going to handle this for you of spinning up servers close to you. Now, we like to be transparent, so let's pull back the covers to see how Unity is really thinking about the implementation itself. On the left, you have your game, and you've uploaded your dedicated server image to the Unity dedicated server orchestration system. And then, we're going to start calling the orchestrator. Now, you might recognize that bit in the middle from earlier, because it's coming from the open source matchmaker. This box in the middle, this thing that we call the hosted environment, that's the thing that people tend to write again and again and again with each of your games. And so that's what we're trying to solve for. But don't be overwhelmed by this, because these green boxes are the ones that Unity is going to provide in that hosted version. So you don't have to build any of those yourself. So, starting to the left, we have the client itself, API itself, that will have a front door that's hosted inside the environment that you're going to talk to. This is where you can submit your customized match information for the player. Now, if we have a look at the stack of boxes on the top left of that hosted environment, you'll see that that's where, in the future, Unity is going to be able to provide services like identity, like skill and invites, party services, and so on. At this point, the custom client information will then be augmented once we get to that matchmaking API part. It will then be augmented with secure information and plugged right into the open source front door, and we'll talk about the match functions in a minute. On the right-hand side, if you notice, we've got a new block there called the allocator. The allocator has two responsibilities. One is that it is responsible for understanding when a match has been minted and it's ready to be secured for a server. It's going to observe where the players are, and then it's going to submit the region back to the orchestrator in the middle to spin up a server with the correct profile for the game mode, with the right hardware allocator, all the way back to your game. So it's going to go get all the details that it needs to and then pass that information back to your game client. Now, it seems like there's a lot going on here, but it happens really, really quickly. I said it had two roles. Its other role is to submit those profiles that we talked about earlier. So you can and you'll be able to configure those, by the way, those profiles in the developer dashboard. You can choose to use a JSON file if you want, but we're going to make this easier for you. And this is where you would mix it correctly. It's up to you to define those profiles so that you can tune your game parameters to be able to scale up and down based on the player population that you have. And then lastly, we have our match functions in the middle. Now, there's a reason that they're not written in green, even though they live in a green box. Because as I mentioned earlier, these are the canonical functions that we're looking to build. But if you start to imagine and map your own game and your own matchmaking concepts over this, you'll probably quickly realize that we can't define a set of functions that applies to every scenario. You might have a game where you need one player that has access to a specific item, and then maybe the other 4 players in that party don't necessarily need it. That's a very specific scenario to your game. And so by building these functions and making them completely open, it means that we can also allow you to have that flexibility where you can define your own match functions for your game and deploy them in here as well. Now, some of those examples, I gave you 1 or 2. It could be that you could have level requirements or gear requirements. Maybe it's a RPG or a MOBA style game where you need a couple of healers and damage dealers, as well as some tanks. You could kind of restrict it in whatever way you want to. The idea behind integrating the open match here is to provide that flexibility directly back to you. So we want to enable you to be able to write your own custom match functions, and we'll provide the tooling, a way to upload it, and then eventually when it's received, we can plug in directly to it in the back end. Unity and Google will handle the scale and the hosting of the runtime for you. This will plug directly into things like analytics, so you can monitor the success and eventually turn on that match function for your match population. You should be able to do most of the things that you want to with this model. We believe that with the flexibility that we've afforded here, we can meet the needs of your online requirements, no matter what kind of criteria that you have. So Unity is getting the benefits of the open source matchmaker, and naturally, through this process, as new things are discovered, Unity is going to be contributing back to that matchmaker, and again, everybody benefits from those contributions. So everything that you saw earlier in that diagram that was in green is currently being worked towards. This is the roadmap. I'm not able to share timelines with you, but we want to be transparent, and we're working very hard on making sure that we can get the infrastructure stood up and have a quick match for you so that you can start integrating with it really quickly. What's really great about this system is that it has all the characteristics, the simple inputs, the customized data, and the idea that retention is measured on the other side. Which means that this problem is ripe to be solved with machine learning and analytics. So Google and Unity's machine learning expertise could possibly provide a machine-learned matchmaking solution that is custom to the needs of your game for creating that right amount of stickiness for your players to keep coming back. I mentioned that the open source matchmaker is now available. You can grab it at this GitHub repository right now. It's in active development, so I strongly encourage you to go grab it, download it, play with it, give us your feedback, and ideally also contribute back to it as well. With that, I want to say thank you, and I hope you have a great night.